All right. The purpose of this video recording is to do a review of 3.1 all the way up to 3.5 in preparation for your test. And this chapter is all about the relationship between lines and the relationship between angles. And so it's important that we know the difference between the two, right? So when I say line, I'm talking about something that looks like this, connected usually with two sorts of points. And then with a line, we're able to find something like a straight line distance, right? Okay, we're able to find something like distance. With an angle, on the other hand, what we are talking about, and the example that I've commonly used is pizza. And what I mean by pizza is that all pizza slices meet at this vertex, right? And so when I say angle, I'm not talking about this distance. I'm not talking about that distance, but rather when I talk about angles, I'm talking about this right here. And so an angle measurement is usually measured in degrees or something called radians, which you will do in higher level math, but for now we don't worry about that, right? But an angle can be measured in degrees. So for example, 67 degrees, right? And as the angle gets smaller, right, the measurement will get smaller, like 25 degrees. And some important angle relationships to note is that when it goes straight up and straight across, this angle can be marked with a kind of box, and that's called a right angle, which is 90 degrees. And then another important one is when an angle goes all the way across like this is called a straight angle, which is 180 degrees, okay? So that's kind of our prerequisite knowledge that we want to have as we go into this section, into this chapter. So let's talk about different types of line relationships. So one of the most basic things we want to know is how two lines can relate to each other. So in general terms, well, so we can say this. So two lines can, and then there's three types of relationships. So the first one is called intersect. So two lines can intersect. And when they intersect, can look something like this, right? And so basically what intersect means is that they meet in some sort of point, right? That's one way that we can think about intersection. And then if we want to get really particular about it, they can have a very special type of intersection called being perpendicular. Perpendicular. And when we say perpendicular, what we are talking about are two lines that intersect in a very particular way, and more specifically when they intersect in what we talked about just previously as a right angle, which is 90 degrees. Okay, so two lines can intersect, which usually means that they meet in a point, but a very special type of relationship, right? So this is a special type of intersection, which is called perpendicular, and when they're perpendicular, they meet in this 90-degree angle, okay? And then two lines can also, they can not intersect. They cannot intersect, which means that they don't meet, right? They never meet in a point. And so when we say that, there's two different options for that. The first is one that we will talk about commonly, which we'll talk about a lot, which is called to be parallel. And when two lines are parallel, I want you to think about it like a railroad track. So when you have a railroad track, right, you have a line here and a line here, and I want you to notice they never intersect. They never meet. But another important attribute of parallel lines is that they are in the same plane, or they are on the same surface. Okay, so something like this, right? They are parallel. And if you remember, the way that we show that they're parallel is by marking them with these kind of feathers. Okay, and then so that's the one that we're going to use the most. Oops. Right, so we will use this. Okay. But the second type of non-intersecting relationship that two lines can have is called skew. Skew. Now, skew is not as commonly talked about, but I think it's important to know what it means. And the best way I can think about it is when you are on a street, for example, right? And then, over the street, there's like this bridge, and then there's like another, let's say like a freeway or a highway above it. And do you notice that when you drive this car underneath the bridge, right, there's also cars that are going over you. And normally, if that was the situation, they would crash, right? However, the highway is above you and you are below it. So regardless of what direction you're going in, you're never going to meet each other, right? So that's what it means to be skew. So skew is basically non-planar. Like you are not on the same surface. I guess that's all that I would really want to say about it. So if I were to kind of draw it out, like imagine a surface like that. Imagine a surface like that. And then if you put a line here and then a line here, and it doesn't matter which direction this line is in, they're never going to meet because they're not a part of the same plane. I hope that makes sense. Okay, so two types of relationships to really pay attention to is this one, perpendicular. Okay, so this is huge. And then also this one, parallel, which is also huge. Okay? All right, so the second part is talking about angle relationships. Thinking about all the different types of relationships that can form when you have parallel lines or when you have two lines cut by a transversal. So, what do I mean by that? You want to be familiar with a few terms. Okay, so you want to be familiar with the term vertical. Okay, number two, you want to be familiar, and then with the terms alternate interior. Angles, alternate exterior angles. And then the fourth one would be same side, or another way they put it is consecutive interior angles. And then number five, just the same thing, but then instead of interior, we're going to say exterior angles. And then lastly, number six, we want to be familiar with corresponding angles. Okay? And so to show you what each of these are, we're just going to draw one basic diagram. And then from there, hopefully that'll make it clear what each of these are. So I want you to imagine we have two lines that are cut by a transversal. This is called a transversal. Okay, and then these are our two lines. So line number one, line number two, right? And every time this kind of relationship happens, we have all these angles that form. So for example, here, angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So we'll always get these 8 angles. Now, these 8 angles have a relationship with one another. So for example, when we say vertical angles, what we were talking about is an angle like this, like angle 1, with angle 4. Or like angle 2 with angle 3. Or like angle 5 with angle 8. Or like angle 7 with angle 6. Okay, so what are vertical angles? They're the angles that are right across from each other. And so an example of this would be like angle 2 and angle 3. Okay? All right, so now let's talk about the next example, which is alternate interior angles. Whenever we have two lines that are cut by a transversal, we can think of it as an interior and an exterior side of the field. So this right here would be considered the interior because it's the area that's in between this line and this line. Do you see that? That's the interior. The exterior would be the part that's outside of the lines. So every time you see two lines cut by a transversal, two parallel lines cut by a transversal, it's easy to visualize it this way, right? To think of interior as the area between the two lines, right? This part is the interior. And then the part that's outside of the lines is called the exterior. And so when we say alternate interior, we're talking about alternating, right? So when you have two lines, well, so when we say interior, we know we're looking here, and we're talking about the angles that alternate like that. Okay, so in this case here, we have angle 2 and angle 7, or angle 4 and angle 5. So that's the way we would write an example out. An example would be like angle 4 and angle 5. Okay, and so alternate exterior then is the same idea, except we look at the exterior angles, right? So here they are. So 1, 3, 6, and 8. And then we want to think about them as alternating. So 1 and 8, right? Or 3 and 6. Right? So an example would be angle 3 and angle 6. Okay, and then the next part is called same side consecutive interior angles. So now we're going back to the interior region, and then we're looking at the same side consecutive. And so what that means is is that we're looking at the angles that are on the same side of the transversal. So like angle 2 and angle 5. Okay, that's what it means to be same side or consecutive. So something like that, right? And so the example here would be angle 2 and angle 5. Okay, or angle 4 and angle 7. Now back to the same side consecutive exterior. So it would be like angle 1. And remember, we're staying on the same side, so angle 1 and angle 6. All right. Or angle 3 and angle 8. All right, and then lastly, corresponding angles. So that's probably the hardest one to visualize because corresponding, you have to look at one exterior, and you also have to look at one interior. Okay, so when I say corresponding angle, we're talking about one interior and one exterior. So notice it's also on the same side, right? So we're not alternating. And yeah, I think that's about it. So like angle 2 and angle 6, angle 4 and angle 8, right? You see one interior, one exterior on the same side. And then like angle 3 and angle 1, and then angle 7 and angle 3. Okay, so there's a ton of examples there that I gave, but just to point out one of them, let's say angle 3 and angle 7 are corresponding angles, okay? So on the test, these 6 angle relationships need to be, kind of like an automatic thing, right? We don't want to just be guessing, because most likely then, you'll miss it. But you want to be able to go, okay, alternate interior, alternate exterior. I know exactly what they're asking me for, right? And all these other relationships as well. Okay. All right. Part 3. So I just want to give a couple of examples of when we have 2 parallel lines cut by a transversal, what the different relationships are. And if you did, all the do nows in class, you would know that there's 2 types of relationships. So either, okay. So the first type of relationship is angles are congruent. And then the second type of relationship is that angles are supplementary. Okay. And so I guess to put it in like more common terms, when I say angles are congruent, all I'm saying is that they are the same size, or they are the same measurement. Okay. And then when I say angles are supplementary, what I'm saying is they add up to 180. All right, so just to give you a couple of examples here, or we'll just do a couple here. So if I give you a line like this, So if I give you a parallel line like this, and they're cut by a transversal like that, and we say that these guys are parallel, and I tell you that this guy is equal to, let's say, x, and then I tell you that this guy is equal to, let's say, 75 minus x, right? Then what I need to do first is I need to look at these angles, these pizza slices, and I need to ask myself, are they the same, or do they add up to 180? And if you remember from the previous page, these angles are called alternate exterior. And one thing that we've learned is that alternate exterior angles are congruent. But even if you don't know that, you can look at this and kind of look at the shape and be like, okay, they're the same shape, right? The pizza slice is the same size. And so because of that, I can set up this equation that x and 75 minus x are equal to each other, and then I can work it out from there. Okay, and notice when I put 37.5 into here, here's my answer for that one. And then when I put 75 minus 37.5, I get 37.5, which is a good sign. Right? So just to make it clear, the ones that are congruent are alternate exterior, alternate interior, corresponding, and then vertical. Okay, so these are the 4 types of angle relationships that are congruent. And then secondly, if it's not congruent, then what they're going to do is they're going to add up to 180. So let me go ahead and draw another example of 2 parallel lines. Like this. And then they're cut by a transversal like that. So if we say, for example, this right here would be, let's say, y plus 2. Okay, and then let's say this guy would be 48 degrees. All right, so these guys are both exterior, and then they're on the same side of the transversal. So these would be an example of same side exterior angles, right? And then once again, when we look at the pizza slice, so this one looks like it's a little bit on the bigger end, and then this one looks like it's a little bit on the smaller end, right? So it would be foolish to say, okay, that they're the same size, right? So the other relationship is that they have to add up to 180. So the way that we write that out is y plus 2 and 48, instead of putting an equal sign here, which we did in the previous example, right? What we would do is we would say that these guys have to add up to 180 like that. And then this becomes another algebra problem. So y plus 50 . So there it is. Right. So the ones that do that are same side exterior, same side interior, and then, you know, the linear pairs that we might see here and there. But, you know, those ones are not, those. That's actually from last chapter, right? But there they are. Okay. All right. So now let's move on to the fourth part, and we're getting to the end here. Is to recognize the slopes of lines. Okay, so notice now we're moving out of angle relationships, which is what we just looked at, right? And we're just looking simply at lines. And if you remember from the slopes in real life, we talked about lines can either we talked about lines as either being uphill, downhill, completely flat, or vertical. Okay, and an uphill line looks something like this. A downhill line looks something like that. A flat line looks completely flat like that, and then a vertical line goes up and down. And so these guys all have a certain type of slope. And slope, you know what, let me just go ahead and... So when we say slope, we're talking about steepness, right? How steep a line is. So, yeah. And in this case, for uphill, we would say that the slope is always going to be positive, right? Because an uphill graph, we're going up. We're going in the positive direction, right? A downhill, we would say that the slope is negative. For a flat, we would say that the slope is 0. And then for a vertical graph, we would say that the slope is what we call undefined. Because what will commonly happen here is we'll get some number over 0 for slope. And so this leads to the number being undefined because you can't divide by 0. Okay, so how do you find slope? So you can either do two things. Number one, you can calculate the rise over the run. Okay, or number two, you can do y2 minus y1 over x2 minus x1, which just means that we take 2 points, and we'll call them x1, y1, x2, y2, and then you find their slope. So a quick example here that I can give is if we have the point, let's say like so let's say we have like -3, 2 and 4, -1, right? Then we can clearly see that this is the x, and then these are the y's. Okay, because the x is always the first number, x, y, z, right? X is always the first number, y is always the second number. And then to classify which one's x1 and y1, we just look at the first one as x1, y1, because it comes first. And then the second one would be x2, y2, because it comes second. Right, and so we can just work it out from there. So m equals -1 minus 2, 4 minus -3. So what I just did was y2 minus y1, x2 minus x1. And so that becomes -3 over 4 plus 3, which is 7. So my slope is -3/7, which tells me that it's a downhill graph. And how did I know that? Because my slope is negative. Okay. Now, before I move on here, just one thing I want to point out is, what about parallel lines and perpendicular lines? So keep in mind that parallel lines, like we talked about at the beginning, are two lines that never intersect. And I want you to notice, if we put a person here and a person here, the mountain that they both have to climb is the same, even though the locations are different. And so what we would say about parallel lines is we would say that their slopes are equal. Right? One line is not more steep than the other. So if this one's slope is, let's say, 3/2, an uphill positive slope, then we would say that the slope of the perpendicular line is also 3/2, right? So this is really helpful for us when we see equations like this, when we see like y equals -2x plus 5, right? And so we can recognize here that the slope is -2. So any parallel line also has slope of -2, right? So once you know one line slope, you know the slope of all the parallel lines around it, okay? The second part is the perpendicular lines. So the perpendicular lines are not parallel, right? They don't have the same slope. It's quite the opposite, actually. So imagine something like this. When perpendicular lines meet in a 90-degree angle like this, right? So the slope here, and then we have a slope of the perpendicular line. And I want you to notice just off the bat, one of the slopes is positive, it's uphill, right? This is our uphill. And then did you notice that one of them is negative? It's downhill. So already we know that the slope of the perpendicular is the opposite. And so when I say opposite, we're saying plus to minus or minus to plus. And then the other part of it is that it's not just the opposite number, but it's the opposite reciprocal. Which means that we flip the fraction, right? So you flip the top and the bottom to get the opposite slope. So just a quick example, if I say that the slope here is equal to 5, then I would say the slope of the perpendicular is equal to the opposite and then the reciprocal. So this one can be written as 5/1. So when we flip that, that becomes 1/5. So there's the slope of one line, and then there's the slope of the perpendicular line. And so in the same way, if I give another example, let's say y equals 3/4x minus 5, we know that the slope of this line is 3/4. So the slope of the perpendicular line would have to be negative because it's opposite, and then we would flip it to be 4/3. Right. So hopefully that's helpful. And then just the last part is having the ability to work through these linear equations. And I talked about 3 different types, right? We have the slope-intercept. We have the point slope. And then we have the standard form. Now, it's called the slope-intercept because we're given a slope, and then we're given something called a y-intercept. And so this one can be written as y equals mx plus b. Right? Yo mama's excellent burrito. And so if I just give a quick example, so y equals, let's say, -3x plus 5. Okay, we are able to use this and graph it on a coordinate axis like this. So if we have an xy graph, we know our y-intercept is 5. So we go 1, 2, 3, 4, 5. We put a point there. And then we use our slope, which is downhill, right, with a rise over run of 3 over 1, right? So down 3 over 1. So down 3 over 1. Down 3 over 1. Like that. And then we're able to graph the line that looks something like that. Okay, now the point slope form gives us a point, and we'll call that x1, y1, and then it gives us a slope, and we'll call that m. So point slope form is simply y minus y1 equals m times x minus x1. So if I say y plus 2 equals 3/4 times x minus 5, I know two things. I know my point, which is always the opposite of whatever you see here. So it would be 5, and then here it would be negative 2, and then the slope would be 3 over 4. Oops. Okay, so what we can do is we can pick a point 5 comma negative 2 and graph it right there. And then we know that's going to be uphill, and it's more specifically, it's going to be up 3 and then right 4, right? So 1, 2, 3, 1, 2, 3, 4, like that. Okay, so 1, 2, 3, 1, 2, 3, 4. So right here, 1, 2, 3, 1, 2, 3, 4. So I connect that, and look, it's an uphill graph. And then lastly, the standard form, which is written as ax plus by equals c. So an example of this would be like 5x plus 2y equals 10. And you know what, let me write that in green. And so to graph this, set x equal to 0, and then also set y equal to 0. So these are things that we're going to do one at a time. So first we set x equal to 0. When that happens, we get 0 plus 2y equals 10, which tells us that y equals 5. So this gives us 1 point, 0, 5. Okay, and then when we set y equal to 0, we get 5x plus 0 equals 10, which means that x is equal to 2. So 2, 0, right? And so what we can do is we go to our coordinate axis, we graph 2, 0, we graph 0, 5, and we've graphed what we call the x-intercept, and we've graphed the y-intercept, and then we can connect those 2 points to make our line, okay? So if you understand these concepts fully, you should be able to do well on this test, all right? So there's different types of relationships between lines, perpendicular, parallel, and then others. There's different types of angle relationships when we have two lines cut by a transversal. We have alternate interior, alternate exterior, same side, interior and exterior. We have corresponding angles, and then even back a chapter, we have vertical angles. When you have two parallel lines cut by a transversal, you want to figure out, are the angles that are formed, are they the same, or do they add up to 180? And then whenever we look at lines, we can determine their slope, whether they're uphill, downhill, flat, or vertical, right? And we find that by using this formula, or we use rise over run. And then we see the relationship between different slopes for parallel and perpendicular. And then we can use these linear equations and we can graph them.